Hello and welcome to the Raman microscope operation instructions video. The first step in using the microscope is to turn on the Raman microscope. You can do this by flipping the switch on the side as shown here. Next, you'll need to log into the computer using your lab's login information and open up the software. Ensure that the option Reference All Unreferenced Motors is checked and then click OK. Once the software is open and turned on, you can then go ahead and power on the laser. After the laser is powered on, you must wait 30 minutes to ensure the laser has adequate time to warm up. To open the door to the Raman microscope, simply hit door release and then open the door. Prior to taking a Raman measurement on your specific sample, you first want to ensure that the laser is aligned and is in the crosshairs. To do this, use the copper tape sample inside of the Raman chamber and mount it onto the stage. The stage can be moved in the X and Y direction by moving the small orange knob shown in this video, and the Z direction can be moved via the coarse adjustment knob in the back. There is also a way to manually change the Z-axis stage to accommodate either a larger sample or bring back to a slide preparation. And if this needs to be done, please contact a representative from Dr. Prasad's lab to do so. Once the copper tape slide is loaded into the stage, use the coarse adjustment knob and X knob to focus the sample. You can view the sample under focus on the software. Find an area on the sample that is relatively flat and pure copper tape. There are two different mechanisms to control the stage in order to focus on a sample and move through a sample. The first is by using the manual adjustment knobs inside of the environment chamber. The second is by using the keypad shown here. The top right button on the keypad selects the fastest movement, and the bottom right keypad button selects the slowest movement. The X and Y movement can be controlled via the ball, and the Z movement can be controlled via the outer ring. In order to use the keypad to focus on a sample, you must first select the speed at which the keypad will control the stage, and then you can use either the ball or the ring to move through the sample. Once the copper tape sample is in focus, close the door to the environment chamber. Next, in the software, click the button that allows you to view both the laser and the sample and turn off the light. Lower the laser power down and then open the laser shutter. This will shine the laser onto the copper sample. You may want to close the pinhole and lower the laser power significantly to see where the laser is shining on the sample. As you can see here, the laser is not in the crosshairs. It is slightly to the left. If the laser is not in the crosshairs, then an auto align must be done. However, the auto align should only be performed by a representative from the Prasad Lab for Materials Research. If you get to this point and realize that the laser is not in the crosshairs, please contact a representative from the Prasad Lab. Here you can see the auto align process. However, please ensure that you do not do this process and instead contact a representative from the Prasad Lab, and one of us will come and conduct this auto align process for you. The auto align process is fast forwarded through here. However, it will be done once a semester regularly. If it needs to be done more frequently than once a semester, please inform us and we will perform the auto align. Once the auto align has been completed, I will recheck to ensure that the laser is now properly in focus. As you can see here, the laser is in the crosshairs and is properly aligned. Now that the laser is properly aligned, I will move on to the next daily check. which is a quick calibration. Go to Tools, Calibration, Quick Calibration. The microscope will now take an internal reference point to the internal silicone and measure the Raman peak of the internal silicone. The shift will be shown on the screen. Draw a box around the peak, around 500. Right-click and select Tools, Curve Fit. Next, click inside of the curve to place the relative curve fit. Right-click, Start Fit. The fit is now shown below the curve. The center point should be approximately 520.5. If the center point is significantly off from 520.5, please contact a representative from the Prasad lab. Right-click, accept the fit, and then close out of the window. The microscope is now ready to take sample measurements. Open up the microscope door and remove the copper sample. When removing samples, ensure that the objective lens is set to 5 so that way you have the most working room to remove and place new samples. Ensure to change the software to be set to the ×5 microscope setting when using the ×5 microscope objective. Remove the copper sample and place your sample. Sample preparation guidelines will differ from sample to sample, so please contact a representative from the Prasad lab or Dr. Prasad to ensure that your sample prep is done correctly. For demonstration purposes, we will be using a polycaprolactone nanofiber sample. First, focus the sample underneath the 5x objective using the coarse adjustment knob. Once the sample is in focus under the 5x objective, switch to the 20x objective and refocus the sample. As shown here, change the software to accommodate the ×20 objective, then change the ×20 objective on the microscope. Refocus the sample. You may have to move through the sample in the X and Y plane to find the specific portion of sample that you would like to measure. Once the sample is focused, close the door to the environment chamber. If needed, for some samples, you may want to use the ×100 lens. However, for most samples, the ×20 lens is perfectly adequate for focusing on the sample and conducting Raman measurements. I will now set the origin of the sample. This will save the X, Y, and Z coordinates into the software and will allow me to return to that portion of the sample. To save the photo of the sample, open a new window, go to Live Video, Snap, Single, and the image taken on the camera will be sent over to the new window. Save the image. Save the image into your appropriate folder. I name my folders by the date and then name each file as the sample type and what objective I'm using to take that photo. The image is now saved. As you can see, I've moved away from the sample origin and then have been able to return to the origin using the Go to Origin button. When focusing on a new sample, it's beneficial to keep the auto contrast and auto exposure turned on. These can be done in the settings button. You can now close out the window showing the image as it has been saved. You are now ready to begin your spectral acquisition measurement. Go to Measurement, New Spectral Acquisition, and choose if you would like a static or extended scan. An extended scan will run for 10 seconds and go over the entire Raman shift wavelength. The static scan will go over a specific portion of that spectrum range. You can change the center, which will automatically adjust the lower and upper bounds of that range. For the purposes of this sample, we will be doing an extended scan. The exposure time is auto set to 10 seconds. However, the laser power needs to be selected. I will start by selecting 1% laser power and 1 accumulations. The laser power is the percentage of laser that will be shown onto the sample. The number of accumulations are how many readings will be taken for that sample. Typically, 1 accumulation is adequate for most samples. However, if you have a sensitive sample, you may want to do 2 or 3 accumulations. This will take 2 or 3 measurements and then average them together. If you are working with a sensitive sample that will burn easily, you want to start with a lower laser power and a lower exposure time. This will prevent the sample from burning. To lower the exposure time below 10 seconds, you must perform a static scan, and therefore pick the spectrum range. As you can see, the Raman microscope is taking a spectrum reading of this polycaprolactone sample here. It is an extended scan, so it will run for 10 seconds, and it is at 1% power. The large peak that was just shown on this measurement is a solar flare. It is a vertical line that shows up on the measurement that is not expected. Solar flares do not happen very often, but when they do happen, it is best to just delete that spectral acquisition and repeat the spectral acquisition. So I will set up a new spectral acquisition measurement, and this time I will increase the laser power to 10%. I will then run this spectral acquisition. At 1% laser power, there is a significant amount of noise in my readings. Therefore, I am increasing the laser power. It is best to use the highest laser power that a material can take to do the Raman spectra. This will result in the cleanest spectra. As you can see, the increase in laser power has created significantly less noise in this spectra. However, there was just another solar flare, so we will go ahead and delete this measurement and retry this measurement. In this next measurement, we will continue to do the extended scan. However, we will use 100% laser power. This should give us a clean spectra. Certain materials cannot withstand 100% laser power, so it is beneficial to start at around 1% laser power and work your way up, checking each time to ensure that the material has not burned. As you can see in the spectra, it is much cleaner and there is significantly less noise than in the prior readings with lower laser powers. This spectra has clear peaks. Now that we have gotten a clear measurement with defined peaks and little to no noise, we will save this measurement. In naming the files, I like to name the material, the objective used, what type of scan was used, the power used on the laser, and then save. It is beneficial to save 2 copies of this measurement, one for analysis and one to keep as just the pure copy. Now we will begin the analysis step. The first step is to go to Tools and Truncate. This will cut off certain sections of the spectra. I typically truncate off my samples to around 500 and then anything past 3,000. The next step in the analysis is to subtract the baseline. It will start by subtracting an 11th order polynomial. However, if you go to Properties, you can change the polynomial order to ensure that you are not subtracting any of the spectra or manipulating the data. You can fiddle around with the polynomial orders and then hit Apply and OK once you like that polynomial. Then accept and the baseline is subtracted. The last step that we do is go to Tools and Peak Pick, and this will label each peak that the algorithm identifies. You can then go ahead and remove specific peak labels by clicking on the point and then hitting Remove Peak Label, so that way only the labels of interest are left. The next feature we will cover is mapping spectral acquisition. This will take multiple Raman analyses across a specific area of your sample. To do this, you first select the shape type that you would like to use. For the purposes of this tutorial, I have chosen a rectangle filled. After you have selected the shape, you can then draw the shape over the video viewer and select the area that you will take the measurements for. You can then manipulate the X and Y coordinates and step size to ensure the area is correct. The number of points in the X direction multiplied by the number of points in the Y direction is the total amount of measurements that will be taken. After you have set the area, you will then continue to set up the spectral acquisition measurement template. It is important to note that a static scan should be done when doing mapping measurements, as an extended scan will take a significantly long time. You can choose the exposure time, laser power, and accumulations according to your material's parameters. The machine will then continue to take individual Raman measurements at each point specified. This may take anywhere from 30 minutes to several hours depending on the area size, the distance between points, and the acquisition time. I have skipped through this and shown directly the results. As you can see the different spectral at each point through the designated area. And you can see how the spectra changes when you are on the fibers versus not on the fibers. This mapping spectra looks good, so I will go ahead and save it 2 times, one as the raw data copy and one copy for analysis. Now that the mapping data has been saved, we will continue to perform the analysis on the entire data set. We will first subtract baseline, which using page up and page down, you can see how this baseline subtraction will affect each data file. Once we have established that the baseline subtraction looks good, you can go ahead and accept for all data sets. Next, we will go ahead and open the data file, the analyzed data file, and perform dynamic mapping analysis. In the dynamic mapping analysis, we will select a specific range from our spectra and focus in on that peak. You can do a signal to baseline or general intensity. Signal to baseline is typically the most useful. You can then see how that signal and specific peak differs within the entire data set. Once you have selected the peak you would like to analyze, you can go ahead and save this signal to baseline intensity data by clicking Save Map. You can then close out the screen and open Mapping Review. Select the map that you just created. This will now show you the mapping data of that specific peak. For this particular map, the white portion of the map shows where the polycaprolactone is, and the black portion shows where the polycaprolactone fiber is not. You can show or unshow maps by clicking the eye icon. In order to edit the map, click LUT control. This will allow you to change the color of the map and change the intensity of the map. You can also create a mask if certain measurements are not done correctly to exclude those squares from the map. There are a variety of different color options that you can choose to best display your map for your specific sample type. Once you are satisfied with your map, you can exit out of LUT control and export the map image or the full image. You can then save these images into their designated folder. As you can see here, the map image has been exported and saved. Once you have finished collecting your Raman results, remove your sample, return the objective to the 5x objective, clear out the environment chamber, and close the door. To turn off the machine, Begin by turning off the laser. Next, you will close out the wire software and log out of your account. Finally, you can turn off the Raman microscope. Please be sure to clean up the Raman microscope room when you are finished. This concludes the Raman microscope training video, and we look forward to see you for in-person training.